So now, instead of giving you a preference relation or binary relation, I give you a utility function, all right? So working with it is kind of easier because, I don't know, I mean, it's a functional form, but it's a weird functional form. It's a minimum of two things, two arguments. This is argument 1, and this is argument 2. Understanding your function is key. So I'm going to minimize my arguments. So whichever argument is giving me the smallest value, my utility is going to be that one. All right. So obviously either first argument is smaller than the second, or the other way around, or the third condition is they're equal. Right. So this is very much like min of xy function, which we will, by the way, talk a lot in later chapters. So how do we, so the question is find the indifference curve of this utility function, indifference curve of the utility function. Well, I did not ask to find the indifference curve of 1, 1, because the next part of this question was asking a bunch of other questions. What is the marginal rate of substitution at point, this is the point, I'm sorry, this is the part that I erased. What is the marginal rate of substitution if at point 1, 1, at point 5, 2, and at point 2, 1. All right, so I did not ask you to find the indifference curve for a specific point, but I just want you to sort of draw the indifference curve, sort of a generic indifference curve. How do we do that? Well, simple. You set this equal to k, right? Remember the indifference curves idea? All the points where you're indifferent to, meaning if there is a utility function representing your preference relation, the utility of those points must be equal to the utility of the, the point 1, 1 or whatever it is that you're trying to create the indifference curve. Their utilities must be the same. So that means you're basically fixing the utility level, and so you're drawing level curves that we learned in math review, or I just sort of talked about. So obviously when k is some generic number, things may be way too abstract because there's x unknown, y unknown, and there's a weird functional form, and then another k unknown. So too many unknowns. Okay, well then reduce the number of unknowns so that things are getting easier for you. Well, can I sort of assume specific x and specific y? Well, that you can't do because you're trying to create an indifference curve. What you can do, you can pick a sort of a specific number for k, all right? And let me pick k, which is divisible by 2 and 3, for example, 6. You'll see why. All right, so now, how do I draw this? So utility of something equals to k, all right? Well, don't forget, the utility is the minimum of 2 arguments. So remember there are 2 cases. Case 1, the first argument, I mean 2x plus y, is less than x plus 3y. And so, therefore, utility of xy is equal to 2x plus y, right? So for all x and y values, where this is less than this, my utility is the minimum of these 2 arguments, which is the first one. Case 2, however, x and y could be such that 2x plus y is greater than x plus 3y. I mean, it's possible. And so in this case then, fine, my utility function is x plus 3y because this guy is the minimum. And then finally, case 3, obviously, 2x plus y is equal to x plus 3y. And then, what is my utility function here? It really doesn't matter, I mean, because the first and the second one are exactly the same. So I'm going to use the first one, okay? Once again, because they're equal, it really doesn't matter whether you write x plus 3y or 2x plus y here. Okay, so what I want to do, if it is a min type of function, you usually start with the third case. I mean, of course, you can start from any part. It's just the analysis goes smoother or easier if you start from this part. Because sort of the simplicity of this part is that both components are the same. So therefore, it really doesn't matter whether you take the first argument or the second argument to calculate your utility function. So everything is easier, trust me. So therefore, this is the thing that I should be finding, right? 2x plus y equals 6. Good. Well, but be careful about this. What does that mean? This 2x plus y equals x plus 3y. Well, it means the following. Just simplify it. That's it. So send x to the left-hand side, y to the right-hand side. So I'm going to have x on the left equals 2y. So whenever x is equal to 2y, the first argument and the second argument are the same. Remember, I'm going to draw my indifference curve on x versus y space. All right, so where is x equals 2y line? It's not 45-degree line, right? Because x is 2 times more than y. So if y is, for example, 1, x is going to be 2. So therefore, just pick one point. It's going to give you the idea. Oops, sorry. This was supposed to pass through this point. So this is, well, I hope this looks like a straight line. X is equal to 2y. So this is a straight line where x is equal to 2y along this. Once again, this is a straight line, and let's make it straight. Okay. All right. So one thing that you should know, I mean, you may not think of it, but you should know. So this area above this x equals 2y line, above it, it's the region where 2y is greater than x. Below this straight line, this blue region, it's the region where x is greater than 2y. You may spend some time to convince yourself, all right? But the idea is the following. On this straight line, it's exactly the case that x is equal to 2y. So here, however, so this is x, this is 2y. Sorry. So this is the x point, this is the y point, and x is 2 times y. And so a point somewhere here, for example, or here, doesn't matter. So here my x is still the same, but y is less. Less than what? Less than 2y. So therefore, all these points are the points where x is greater than 2y. And here, for example, any point here, my x is the same, but my y is greater than 2y, because this is the 2y point in a sense. So therefore, this is the area where 2y greater than x. All right? You may have a different, your mind may operate under a different logic, which is fine, but convince yourself that this is the case. So I basically divide my r squared plus world into 3 regions. Region 1, x is equal to 2y. Region 2, 2y greater than x. And region 3, x is less than 2y. Okay, so now I'm going to continue with, how much time do I have? Okay, so let's continue with this logic. Let me carry this graph here. So this is x, this is y, and this is my y equals, x equals 2y. X equals 2y. And if you remember from, intermediate micro or advanced micro courses, this is going to be the kink point for your indifference curve. So by the way, remember I am trying to find the indifference curve where my utility is equal to 6. So now, remember, let's first figure out what this point is? Well, it has to be this, x is equal to 2y, and it also satisfies this, 2x plus y equals the 6 units of utility. Well, then what is this x and y? Well, simple, just solve this. X is equal to 2y, so if you plug this into the second equation, you're going to get 4y plus y equals 6. All right, that was my mistake. I apparently did not do the calculation. So 5y is equal to 6. If you like, you can change the utility level at this point because none of our calculations depended on 6 here, all right? But I'm not going to do it. Let's leave it as it is. So it's 6 over 5. So this is y, and therefore x is 2 times y, so x is equal to 12 over 5. So 6 over 5 is like 1.2, not like exactly 1.2. And so x is equal to 2.4 then. So therefore this point is 2.4, or I don't know, 12 over 5. And this point is what? 1.2. So this point, exactly this point, gives me utility 6. All right. Well, now remember, I want to find other points which give me the same utility level 6. But other points are going to be in this part or in this part because I'm done with x equals 2y. There's going to be no other point on this line which is going to be giving me the same utility level. Why is that? Well, if there is any other point on this line which gives me 6 units of utility, then that means the systems of equation must have more than one solutions. But it has just one solution. Therefore, there's only one point which is going to give me 6 units of utility on this line. As simple as this. Okay, what about in this region? What are the x and y's that are going to give me 6 units of utility? Remember my case, oh yeah, okay, so here's the thing. What does this inequality means? Let's transform this, let's simplify them. This inequality means if you send x to the left-hand side and y to the right-hand side, it's going to be x less than 2y. And this inequality means, once again, if you send x to the left-hand side, y to the right-hand side, you're going to have x greater than 2y. So, 2y greater than x, this region, upper part of my straight line, it's 2y greater than x. The case 1. All right? So whenever x is less than 2 times 1, my utility function is 2x plus y. So therefore, I have to draw the indifference curve of this line, which is equal to 6. All right? So what is when, let me write it, x is less than 2y, all right, we are in this region. My utility function, we already argued previously in case 1, is equal to 2x plus y. So what is the indifference curve, which gives the utility level 6, is basically this straight line, okay? So what is 2x plus y equals 6 line will look like? Assume that you did not draw this straight line, just draw this 2x plus y equals 6 line, all right? How do I draw it? Simple. When y is 0, x is going to be 3. So this is 3. And when x is 0, y is going to be 6. Let's suppose this is 6. So therefore, this 2x plus y equals 6 line has to be a straight line combining this point 3 and this point 6. However, if you do the math, you're going to see that it also passes through this point 1.2, 2.4. All right? You just need to do the math. If x is, for example, 2.4, it's 2 times 2.4, which is 4.8, plus y, which is 1.2, plus 1. So if you add them up, you're going to see it's equal to 6. It's not a coincidence, all right? It has to be the case, because remember, my utility at this point is either the first argument or the second argument, doesn't matter. For that reason, this point has to be on this line. Okay, so here's the thing. Be careful. My indifference curve is going to be the straight line when x is less than 2y. I mean in this region. So this part is not, this part of the straight line is not part of my indifference curve, because in this region below the x equals 2y, the points do not satisfy x less than 2y. All right? So this is one part of the indifference curve, and then the final part of my indifference curve is when x is greater than 2y. X is greater than 2y. I mean, we are now below the straight line. In this case, we know the utility function is equal to x is greater than 2y, this, x plus 3y. And so I need to draw, find all the points, x and y's, which are going to give the utility 6, which means draw this straight line, x plus 3y. How do I draw it? Again, assume that I didn't draw anything here, just draw this straight line. So when y is 0, x is 6. Let's suppose this is 6. And x is 0, y has to be 2. Let's suppose this is 2. So I have to combine these 2 points. But again, if you make the calculation, you're going to see that this straight line also passes through this point. And I put the dots here because I know that this straight line is valid only when x is greater than 2y. I mean below the straight line, x is equal to 2y. Otherwise, above it, it's not my utility function. So therefore, they are not part of my indifference curve. Point is, therefore, my indifference curve is this weird looking shape. It's not L shape exactly, okay? But I have my indifference curve basically, let me draw on a different picture, if you like, x, y. So my indifference curves are going to be moving on x equals 2y. And this is how they're going to look like. This is just when utility is 6. If you increase utility, you're going to get another indifference curve. But trust me, it's going to be perfectly tangent to one another in this fashion, obviously. So this is how my indifference curves will move. Okay? Any question? Well, then let me finish what I started. For the second part of this question, I don't need the indifference curve. All I need is this partition, because all these points are going to correspond to a different partition of this, of an indifference curve. So what is the marginal rate of substitution when the bundle is 1, 1, when the bundle is 5, 2, and when the bundle is 2, 1? Okay, so when the bundle is 1, 1, what is the utility of 1 and 1? Well, it's the minimum. Remember 2x plus y, so it's 2 times 1 plus y, comma, x plus 3y. So 1 plus 3 times 1. So this is 2 plus 1, 3. This is 1 plus 3, 4. The minimum of these 2 is equal to 3. Agree? Okay. What does that mean? That means, I don't really need to calculate the utility, but I needed it because I need to see where exactly 1, 1 located on an indifference curve. 1, 1 is going to appear on a totally different indifference curve than 2.4, 1.2, all right? Because its utility is not 6, as you see, its utility is 3, so it's going to be on a lower indifference curve. But what I needed is that where exactly? Is it on the upper half or lower half? Or is it on the corner of my indifference curve? And when you see this, the 1, 1 point is located on, by the way, let's put here, this is 2y greater than x. So this is u of xy equals 2x plus y. And this is where u of xy equals x plus 3y. So the 1, 1 point is on the sort of upper half of my indifference curve, because 2x plus y was minimal or smaller than x plus 3y. So therefore, when my bundle was 1, 1, the utility function was in fact equal to 2x plus y. So therefore, what is marginal rate of substitution? Marginal rate of substitution is the derivative of the utility, derivative of the indirect, I'm getting tired, it seems. The marginal rate of substitution is the slope of the indifference curve. All right, so that's what I'm trying to figure out. What is the slope of this indifference curve? Clearly, the slope of this indifference curve has three important points. If we are on this part of the indifference curve, the slope is simple, right? It's minus 2, the marginal rate of substitution. If we are on this part, the marginal rate of substitution is minus 1 over 3. And if we are on the corner point, the marginal rate of substitution is undefined because this indifference curve is not differentiable at this kink point, and so the slope is undefined. So therefore, this is why I wanted to figure out where this 1, 1 located at. And as I argued, it's located at the upper side, meaning 2x plus y line. And at this point, marginal rate of substitution of 1, 1 is equal to del u del x del u del y, but u is this guy, don't forget. So it's a minus, don't forget the minus sign, which I do, 2 divided by 1. So it's minus 2. Okay? Well, what about 5, 2? What is the marginal rate of substitution of this point? Well, again, where is it located? Let's figure this out. Oops, sorry. So 2x plus y, comma, x plus 3y. So when x is 5 and y is 2, so this is 10 plus 2, 12. And this is 5 plus 6, 11. The minimum of these is 11, obviously. But the thing is, this 0.52 is located on the lower half. And so therefore, this is not 1, 1, this is 5, 2. So the marginal rate of substitution at 0.52 is equal to minus del u del x del u del y. But this time u is equal to this guy, all right? So the u star, let's call it. U star is equal to x plus 3y. And so it's equal to minus the partial derivative with respect to x is 1, partial derivative with respect to y is 3, so it's minus 1 over 3. And what about 2, 1? Well, I'm going to skip this, but if you do the math, you're going to see that this part, the first argument is equal to the second argument, and therefore this 0.21 is on an indifference curve, but it's on the corner. And so, as I argued earlier, because this indifference curve is not differentiable at the corner points, remember the corners are never differentiable. There are the points where their derivative doesn't exist. So therefore, the marginal rate of substitution at 0.21 doesn't exist, or undefined. Defined. Okay? So basically this is how we figure out indifference curves of this utility function, min, of 2 arguments. And there's another example where I ask the max of 2 arguments, which is pretty much the same. But instead of looking at the min, we are looking at the max of 2 arguments. But the approach is very, very similar, guys. And so I'd leave it as an exercise to you. Any question?